Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And I thought you might find it interesting to talk about the upper atmosphere a little bit and actually show you some actual measurements that were taken by the radiosonde that is carried upward by the weather balloon and what it observed over Greensboro today. And so we're going to talk about temperature variations and wind variations and mass variations and all that stuff. So let me go on ahead and get started here. And the first thing I'm going to talk about is the fact that the pressure, the air pressure, does not decrease linearly with height, okay? It actually is what we call a logarithmic relationship, where the pressure decreases with height very rapidly in the low levels of the atmosphere, and then you have to go up greater and greater distances to achieve the same reduction in pressure from that point forward until it gets way up there, and then the air is has a very, very low density. So this curve here basically shows you that, and standard atmospheric pressure is 29.92 inches of mercury. So by the time we get to 20,000 feet, we have already eliminated 58% of the mass of the atmosphere. 58% is below that level, 42% is above it. Then, by the time we get to 40,000 feet, then we only have 17% of the mass of the atmosphere above us and 83% below us, okay? And then as you can see, the line begins to sort of flatten out, and so you can go up a great distance at high altitudes and not decrease the pressure all that terribly much. So here is and I showed you this the other day, a diagram that meteorologists use to plot soundings. And this is called a skew-T log P chart. Now it's called skew-T because the lines of equal temperature are skewed, oriented like this, okay? And then over here, and I know these numbers are very small, so I wanted to highlight a couple of them for you. So 1,000 millibars is down here. This is 800 millibars here, 600, 400, and 200, okay? Let me go back. So you see how the distance between these labels is getting bigger and bigger, okay? So the same amount of mass between 800 and 600, but you don't have to go up nearly as much distance as you do to go up 200 millibars here. It requires much more distance because the air is less dense. Okay, so twice a day all over the world, weather balloons are launched, and there is an instrument called a radiosonde, which is attached to it, and the balloon carries the radiosonde up through the atmosphere to very, very high altitudes, as you'll see in just a second. And basically it takes readings of temperature and dew point, and then by tracking the balloon, you can see what the winds are like from one level to the next, okay? And by simply doing some trigonometry, you can figure that out. So this is what the balloon information looked like today. And I'm going to start very near the surface, which was 968 millibars. Now, Greensboro, I believe, is about 800 feet above sea level, okay? So that was the sea level pressure observed there today. Now, at that level, it was 886 feet, okay, above the ground, or above sea level. And then the temperature was 51, and the wind was out of the southwest at 9. Now, as we go up, notice over here on this column that the wind rapidly increases to 35, and then it drops off a little bit. And we see this a lot, and we call this a low-level jet, where you have this area usually around 4,000 or 5,000 feet, maybe down around even as low as 3, where you'll have this low-level jet that'll be very, very strong. And part of that is due to the fact that friction is reducing the wind near the ground, and so up there, there's no friction, and so the wind is able to increase very rapidly with height. And then above that, it actually drops off a little bit. Okay, so as we continue to go up through the atmosphere here, by the time we get to 700 millibars, which means that 70% of the mass of the atmosphere is still above us, and 30% we've already gone through. The height there is 9,600 feet, temperature's down to 29, wind out of the west-southwest to 29. Then we get to 500 millibars, which is a standard level that meteorologists look at for the general steering currents in the atmosphere. So today, that was a little over 18,000 feet up. Temperature was -2, this is in Fahrenheit, and the wind was out of the west-southwest at 55. Now, let's jump to 300 millibars. Now we're almost at 30,000 feet. The temperature is 55 degrees below zero, and the wind is sustained out of the west at 83 miles per hour, okay? So when the wind increases with height, what that's telling you is that you have a temperature gradient over you, okay? So it's definitely colder to the north and warmer to the south, depending on how those isotherms are oriented. But anytime you have a temperature gradient, you are going to get winds that are going to increase with height, and the stronger the gradient, the more rapid that increase is going to be. Okay, and then finally, we get all the way down here to 100 millibars, which is 53,000 feet above the ground, or above sea level. Temperature is 69 degrees below zero, and the wind is west at 75. Now, believe it or not, the balloon goes even higher than that. So I thought you might be interested in seeing that data as well. So I was able to find data at intervals of every 10 millibars except at 40. They didn't record a specific number at that, so I just took the closest one, the 39.6. So by the time we get to 50 millibars, we're now at 67,000 feet up. The temperature is 81 degrees below zero, but look how the winds have dropped off. And you see this a lot, that once you get above the troposphere, which is where we live and most of the weather occurs, then the temperature can either increase with height or go steady with height as we head into the stratosphere. And the overall temperature gradient reverses, okay? And so as a result, in other words, instead of it being colder to the north and warmer to the south, now it's warmer to the north and colder to the south, and so the winds actually begin to decrease with height, okay? So if you have a regular temperature gradient, like something we would be accustomed to, cold north, warm south, then the winds are going to increase with height, but then if you reverse that gradient, so it's warmer north and colder south, then the winds decrease with height, and we certainly see that here. It was up above 80, and now it's down to just 18. And the last level that measurements were taken was at 10 millibars, 100,394 feet up, which is about, what would that be, about 20 miles? Yeah, about 20 miles up. Temperature actually warmed to -59, and the wind from a completely different direction, north-northeast at 39 miles per hour. So these balloons get pretty high up as long as there's not a big thunderstorm around to disrupt them. And it's always interesting to me to see, what it's like that high up and how things are so different there than they are down here at the ground or even in the lowest several thousand feet. So I just thought you might find that interesting. That was again above Greensboro today. They launched that balloon. I think they actually launch it a little bit before 7 o'clock because they want to have all the data in by 7, which is the observation time. So they may actually launch it about 6 or 6:15. It takes some time to go all the way up to that high altitude. All right, folks, that is bonus weather video number 3 for this week. Hope you found that at least mildly intriguing. The next daily weather update and next bonus weather video will be coming up on Monday. You all have a wonderful Friday evening, an even better weekend, and we'll talk to you again first of the week. Take care, everybody.